Here's a justification of the alternating series test for series convergence. So, first, what is an alternating series? It's a series made up special of positive terms, but each one multiplied by a plus or minus toggle switch created by -1 to the power of n minus 1. Because notice, if n is 1, then this is -1 to 0, that's positive 1. If n is 2, 2 minus 1 is 1, -1, the first power is -1, and so forth. So this is going to toggle between 1 and -1, creating this sequence of terms. See, all the A3, A2, A3, A4, they're all positive terms, but the -1 toggle makes it be positive, negative, like that. So this test says that kind of series will converge if these two conditions are met. First, that the next term, an plus 1, has to be less than the previous term. In other words, the terms are getting less and less and less. And the limit of them has to be 0. If those two conditions are met, then the alternating series will converge. So here's just another explanation of that. An alternating series is a series where each term consists of positive terms multiplied each one by a plus or minus toggle, which looks like this. The alternating series version of this one, for example, this is the original series without alternating. It's just 1 plus a half plus 1/4 plus. So the alternating series version of this is this one. All you do is take those terms and hit them by the plus or minus 1 toggle to create 1 times it, -1 times it, 1 times it, -1 times it, which ends up being this series right here. 1 minus a half plus a fourth minus an eighth, etc. That's how you obtain an alternating series. Okay, so the justification for the alternate series test. First, we just outline what it is again. Here's the alternating series. It looks like this: A1 minus A2 plus A3 minus A4. And each successive term is smaller than the one before. So that's important. The terms are getting smaller in absolute value. So let's look at the partial sums. The justification of the alternating series test looks at partial sums. S1 just adds up A1. So let's say you have 0 on the real line here. Your A1 adds up and takes you all the way to here. And that's what your S1 is, because S1 is A1. Then S2 starts off where you were and subtracts off A2. So you go back a ways, back to here, and that's where S2 is. Now let's see what happens increasing with that procedure. We're going to see an animation of the partial sums, and it's from this site created at the University of Tennessee, Knoxville. Here's the applet showing this justification of the alternate series test. So we're going to start on this real line here. I'm going to click continue. Sure enough, the first term, A1, is positive, takes you all the way forward to S1, the first partial sum. Then you click here, and A2 is negative. There's a negative sign in front of that A2, so that takes you back to here, subtracts off, and ends up somewhere around here with S2 being here. So S2 consists of A1 adding to there and then subtracting off A2. Where's S3? S3 takes off where you were at S2 and adds on S3 because there's a plus sign in front of the A sub 3 because it's alternating. So it ends up S3 here. Where's S4? Oh, S4 takes off where S3 was, but the sign in front of the A4 is negative, so it takes you back to here, so S4 is over here now. So you can see all the odd number partial sums are on the right, and all the even are on the left, and they seem to be approaching some point in the middle somewhere. Here's A5, taking off where S4 was and adding, so you get S5 right here. And S6 appears right here. And then you can see how that progresses. So then somewhere there's going to be a limit in there. And I think you see and believe that in the end they come out right somewhere here and converge together. In other words, the even ones increase up to a point, and the odd ones increase down to a point, and they meet somewhere, and that's where the partial sums converge, like that. So if the partial sums converge, then the series converges. So that justifies the alternate series test.